focus of this video is on APA-style interpretation for the independent samples t-test. Before we discuss how to complete the APA-style interpretation, let's review the example and the work that we do in steps 1 through 3 to get the values that we need to fill in the blanks of an APA-style interpretation. This is going to be a quick review of steps 1 through 3. Feel free to pause the video if you'd like to complete some of the work as we're going through it. Otherwise, this is really just an overview of what needs to be done in step 1 through 3. And the primary focus is on how do we make sense of the values that we compute. So our example here is we're looking at two different groups. We have 6 participants who are assigned to what is called a depletion group or mentally tired, and then 6 participants who are in the non-depletion group, which is considered mentally sort of fresh. And we're looking at the differences in ratings of willingness to make sacrifices for their romantic partner or best friend, and that's our dependent variable. So we're really looking at the differences in what is called pro-social behavior, which is the behaviors that we do for the benefits of others. So let's go into step 1 and step 2. So for step 1, as we know, we're going to state the null and alternative hypotheses. And then step 2, we're going to start with our computing the degrees of freedom total. So what that looks like is we're taking the degrees of freedom for group 1 plus the degrees of freedom for group 2, and we're combining them. So N1 minus 1 plus N2 minus 2. So we have 6 participants in each group. So 6 minus 1 is 5, plus 6 minus 1 is 5, and that 5 plus 5 equals 10. So we're using 10 degrees of freedom to look up our critical values in the t-table. So we're going all the way down to degrees of freedom of 10, and we see that our critical values here are plus or minus 2.228. So we can label our model of the distribution, the sampling distribution, as if the null is true with an alpha level of 0.05. So our critical values are labeled, and then the center of the distribution is labeled M1 minus M2 equals 0. So when the null hypothesis is true, there's no difference between these two groups. And once we've set up step 1 and step 2, we can move into step 3. The first thing that we need to do is complete the sum of squares table for both groups so that we can get the mean, and sum of squares so we can compute the other values that we need to compute in step 3. So for our depletion group, here's our setup for the sum of squares table. Feel free to pause the video if you want to complete this table on your own. Otherwise, this is the completed table with the mean and the sum of squares. So our mean is 7, our sum of squares is 28. For our non-depletion group, again, if you want to pause and complete the table, this is how it's set up. Here's our completed table. They have a mean of 3 and a sum of squares of 22. Okay, so that's our completed tables. Now we can move on to computing variance and standard deviation for both groups. So for our depletion group, the sum of squares divided by degrees of freedom, that's how we compute our variance. So it's 28 divided by 5. Our variance for the depletion group or group 1 is 5.60. Then we do the same calculation, but now we're getting the square root. So it's the square root of the sum of squares divided by degrees of freedom, and that gives us 2.37. We do the same process for the second group, non-depletion group. So we have our variance, which is 22 divided by 5, which gives us 4.40. And then our standard deviation is the square root of 22 divided by 5, and that's 2.10. So here's a summary of what we've done so far in step 3. We've computed the mean, the variance, standard deviation, sample size. We've also computed the degrees of freedom total, which is not included in this table. Now we can move on to the next part of step 3, which is about computing standard error difference and t observed. So the standard error difference is we're taking the square root of the variance for group 1 divided by the sample size of group 1 plus the variance for group 2 divided by the sample size for group 2. So what that looks like in our example is the square root of 5.60 divided by 6 plus 4.40 divided by 6. And this gives us a standard error difference of 1.29. We need this value for the denominator of the t observed. What's in the numerator is the mean difference, the difference between mean 1 and mean 2 divided by the standard error difference. So what that looks like for our example was 7 minus 3 divided by 1.29, and this gives us a t observed of 3.10. Then we can move back to our model, locate our t observed, which is more extreme than our t critical. It falls in the rejection region, therefore we reject the null hypothesis just based on what we see right here, the comparison between our t critical and our t observed, the location of it in the rejection region, and we're saying that our results are statistically significant. The next part of step 3 is constructing our 95% confidence interval around the mean difference. So that looks like this. We're taking mean 1 minus mean 2 plus or minus t critical times standard error difference. We've had a lot of experience constructing confidence intervals over the course of the last few topics. So let's look at what this looks like for our example. So our mean difference here is 7 minus 3, so those are our means, plus or minus the t critical, which we just found based on our degrees of freedom total of 10, times our standard error difference, which we just computed, which is 1.29. So our mean difference, 7 minus 3, is 4, and then we multiply our t critical times our standard error difference, which gives us 2.87. So then when we take 4 minus 2.87, this gives us our lower bound estimate of 1.13, and then 4 plus 2.87 gives us our upper bound estimate of 6.87. And so that's where we are currently. We can say at this point, looking at this confidence interval, 0 is not included in this range of values, which is what we would expect since we rejected the null hypothesis. The last part of step 3 that we're going to compute is our effect size, or Cohen's d. The first thing that we need to do for an independent samples t-test is compute the standard deviation pooled, or the pooled standard deviation. That goes in the denominator of Cohen's d. So what that looks like is our square root of the variance for group 1 plus the variance for group 2 divided by 2. So it's the square root of 5.60 plus 4.40 divided by 2 gives us our standard deviation pooled of 2.24. We put that in the denominator, and in the numerator, again, we have our mean difference, 7 minus 3. So our Cohen's d in this case is 1.79, which is a large effect. So what this looks like in our example here, if we look at this graph, we can see the pattern of the results here. So we can see for our depletion and non-depletion, we see one is higher than the other. The height of the bar really represents the mean. So if we're looking at the average willingness to sacrifice for loved ones or a best friend is higher for the depletion group than it is for the non-depletion group. And we can just see this pattern, which really helps us think about our interpretation. So that's part 1 of the independent samples t-test. In the next video, we're going to talk about how do we use these values to help us construct our APA style interpretation by filling in the blanks.